Every year we chip away at the stone of reality, seeking the fundamental rules that govern the cosmos. We build colossal machines to smash particles and design telescopes to gaze back to the dawn of time. Most years we find small, incremental clues. But 2025 was different. This was a year of cracks and bridges. Cracks in our most cherished theories, and new bridges built between the bizarre world of the quantum and the reality we see and touch. From the heart of the atom to the fabric of space-time itself, these are the top 10 physics breakthroughs of 2025. Number 10. A star in a bottle. For decades, nuclear fusion has been the ultimate clean energy dream. In 2025, a revolutionary stellarator reactor in Germany, using a twisted complex magnetic field, sustained a stable plasma reaction for a record-breaking 30 minutes, finally achieving a net positive energy gain. It was a monumental step, proving that the technology to build a miniature controlled star here on Earth is finally within our grasp. Number 9. The quantum ghost detector. Scientists in the Netherlands developed a groundbreaking sensor using quantum entanglement. By linking pairs of photons, they created a system so sensitive it could detect the faint gravitational pull of a single human being walking in an adjacent room, right through a solid wall. This quantum-entangled radar opens a new era of non-invasive sensing for everything from geology to medicine. Number 8. The sound of a starquake. The global network of gravitational wave observatories, LIGO and Virgo, detected something unprecedented: the faint, high-frequency ring of a neutron star's crust cracking under its own immense gravity. For the first time, we didn't just see a star, we heard the sound of its surface shattering, a starquake that sent ripples through the fabric of space-time itself. Number 7. A new state of matter. At the University of Cambridge, physicists finally stabilized a bizarre and long-theorized state of matter known as a quantum spin liquid. In this state, the electrons in a material refuse to freeze into a stable magnetic order, even at absolute zero. They remain in a constant, entangled, liquid-like dance, a property that could become the foundation for fault-tolerant quantum computers. Number 6. The galaxy without a ghost. Dark matter is the invisible scaffolding of the cosmos. Every galaxy should be built upon it. But in 2025, new observations of an ultra-diffuse galaxy named UGCJ 1228+1510 revealed the impossible: a galaxy with no dark matter at all. The discovery sent shockwaves through cosmology, suggesting that either our theories of dark matter are incomplete or that gravity itself behaves in a way we simply do not understand. Number 5. Solving the proton puzzle. For years, a nagging mystery has haunted particle physics. How big is a proton? Different experiments gave frustratingly different answers. In 2025, a new ultra-precise electron scattering experiment at CERN finally pinned down the proton's charge radius, solving the discrepancy. The result has forced theorists to reevaluate our understanding of the strong nuclear force that binds the universe together. Number 4. The Nobel Prize for Walking Through Walls. Physics World's breakthrough of the year was awarded to the team whose work led to the 2025 Nobel Prize, the definitive observation of macroscopic quantum tunneling. They proved that a circuit made of billions of atoms could, in unison, tunnel through an energy barrier it didn't have the energy to cross. They brought the ghostly rules of the quantum world into our own, building a tangible, artificial atom that is now the bedrock of quantum computing. Number 3. A solution to the warp drive's death ray. The Alcubierre warp drive has always been plagued by a fatal flaw. Upon arrival, it would release a blast of deadly radiation. In 2025, a team of theoretical physicists published a groundbreaking paper proposing a new geometry for a warp bubble. Their solution, involving a quantum vacuum regulator, suggests it's possible to build a warp drive that can be safely turned on and off, transforming it from a theoretical weapon into a plausible vehicle for interstellar travel. Number 2. The first crack in the Standard Model. For 50 years, the Standard Model of particle physics has been the undefeated champion of science. In 2025, at the Large Hadron Collider, physicists observed the Higgs boson decaying in a way that is strictly forbidden by the model's rules. It was a tiny anomaly, a 1 in a billion event, but it was the first definitive crack in our perfect theory, a signpost pointing the way to a new, deeper physics that lies beyond our current understanding. And the #1 physics breakthrough of 2025, the whisper of gravity. We have particles for electromagnetism and for the strong and weak nuclear forces. But for gravity, we had nothing. The graviton, the hypothetical quantum particle of gravity, has been the missing piece of physics for a century. In 2025, a next-generation gravitational wave observatory, analyzing the faint background noise of the universe, made a discovery of staggering importance. They isolated a faint, high-frequency hiss in the fabric of space-time, a signal with the exact properties predicted for a background of primordial gravitons left over from the first moments of the Big Bang. It is not yet a single graviton, but it is the first direct evidence that gravity, like all other forces, is quantized. It is the first whisper from the quantum realm of gravity, a monumental first step towards a true theory of everything. From a star in a bottle to the echo of creation itself, 2025 was a year that challenged what we thought we knew. It was a year that reminded us that the map of reality is not finished, and that the ink is still wet. For every mystery we solve, the universe presents us with a new, more profound question, forever calling us deeper into the unknown.